Please, you are all welcome to the session 5 of Unit 2, Addition Law of Probability. So by the end of this session, you should be able to state the general addition law of probability and state it for mutually exclusive events. You should be able to also apply the general addition law of probability to solve problems, and also apply addition laws of probability for mutually exclusive events to solve problems. Addition rule of probability. Now we talk about addition rule of probability. These rules are used to determine the probability of two or more events. That's all. So for instance, probability of A or B is the same as probability of A union B. Now, coming back to the general set theorem, the set theorem. If you have a number of A union B is equal to the number of A plus number of B minus number of A intersection B. So it follows that the probability of A union B should also be equal to probability of A plus probability of B minus probability of A intersection B. And this is what we call the general addition law of probability. That's the general addition law of probability. But we're talking about two events here, event A and B. Suppose those two events are mutually exclusive events. You know what I mean by mutually exclusive events? That those two events cannot occur together. Just like a toss of a coin. And toss a coin, you cannot have a tail at the same time head. One event will preclude the other. So suppose event A and B are mutually exclusive events. Then A intersection B will be an empty set because the two events cannot happen. So they are mutually exclusive. The occurrence of one prevents the occurrence of the other one. So this implies that the number of A intersection B will be equal to what? 0. And if you are dealing with probability, the probability of A intersection B will be equal to 0. So for a mutually exclusive event, probability of A union B is equal to probability of A plus probability of B. Yes. Because the probability of A intersection B will be equal to 0 and to have no part to play when we are dealing with this. So this is called addition law of probability. For what? For mutually exclusive events. Remark. Now we made mention of A and B. Well, this rule can be extended to 3 or more events. For example, you can have probability of A union B union C. For a mutually exclusive event, probability of A, that will be equal to probability of A plus probability of B and plus probability of C. Let's start with a nice example. Example 1. A box contains 3 red, 2 yellow, and 5 green balls. If a ball is selected at random, what is the probability that it is, you have a couple of them, A, red, B, yellow, green, C. Sorry, A, red, B, yellow, C, green, D, either red or yellow, E, either red or green, and F, either yellow or green. So the box contains 3 red, 2 yellow, and 5 green balls. And if a ball, so just one selected. So let's move on with this, the solution. So let T should denote the total number of balls, and R to denote the event that the ball is a red ball, Y denote the event of a yellow ball, and G denote the event of a green ball. Then what it means is that the total number of T, the total will be 10, and number of red is 3, number of yellow 2, and number of green is 5. So let's take the A part of the question. The A part, probability of red. How many red do you have? That is 3. Out of how many balls? 10. So 3 out of 10. Probability of Y, that was 2 out of 10, the same as 1 over 5. And then probability of green, that is 5 out of 10, that is the same as 1 over 2. Now probability of P, that's a D, probability of R union Y, that is either red or yellow. It is the same as probability of R plus probability of Y, because it is mutually exclusive. The two events cannot happen together. You cannot have a ball which is yellow at the same time red. So that solution will be 3 over 10 plus 2 over 10, where 3 over 10 is for the red balls and the 2 over 10 is for the yellow balls. And then with the algebra very well, we should get 1 over 2. With the E part of the question, we're talking about red or green, and the same procedure as we saw in the D part. So red 3 over 10 and the green 5 over 10, and that gives us 8 over 10, which is the same as 4 over 5. Now the probability, the F part, the probability of red or yellow or green. That gives us what? All the 3 events. And when we add them, we have 1. Just 1. Thank you very much. And we look forward to the last session of this unit 2. That will be session 6.